Assalamualaikum warahmatullahi wabarakatuh. Saya Rusdiatul Zahirah binti Ahmad Ramizu. Nombor matrik saya 058922. Saya dari Diploma Teknologi Maklumat.
Assalamualaikum warahmatullahi wabarakatuh. Saya Siti Hawa Sofia binti Syakil. Nombor matrik saya ialah 057501. Saya merupakan pelajar Diploma Teknologi Maklumat daripada Fakulti Informatik dan Komputeran.
Nama saya Nur Ain Amira binti Azhan. Nombor matrik saya 058963. Saya merupakan pelajar Diploma Teknologi Maklumat dari Fakulti Informatik dan Komputeran.
These are 4 types of memory access methods. First, sequential access. In this method, the memory is accessed in a specific linear, sequential manner, like accessing in a single linked list. The access time depends on the location of the data. Application of this sequential memory access are magnetic tapes, magnetic disks, and optical memories. Second is random access. In this method, any location of the memory can be accessed randomly, like accessing in array. Physical locations are independent in this access method. Applications of this random memory access are RAM and ROM. Third, direct access. In this method, the particular location of the memory can be accessed directly, like accessing in array. This method is a combination of above two access methods. The access times depends on both the memory organization and characteristics of storage technology. The access is semi-random or direct. Application of thus direct memory access is magnetic hard disk, read or write header. Last, associate access. In this memory, a word is accessed rather than its address. This access method is a special type of random access method.
In cache memory, data is transferred as a block from primary memory to cache memory. This process is known as cache mapping. There are 3 types of cache mapping: associative mapping, set associative mapping, and direct mapping. I will explain about the difference between direct mapping, associative mapping, and set associative mapping. The first one is associative mapping. In associative mapping, both the address and data of the memory word are stored. The associative mapping method used by cache memory is very flexible one as well as very fast. This mapping method is also known as fully associative cache. Permits each main memory block to be loaded into any line of the cache. The second one is direct mapping. In direct mapping cache, instead of storing total address information with data in cache, only part of address bit is stored along with data. The new data has to be stored only in a specific cache location as per the mapping rule for direct mapping, so it doesn't need replacement algorithm. Maps each block of main memory into only one possible cache line. The last one is set associative mapping. In set associative cache memory, 2 or more words can be stored under the same index address. Here every data word is stored along with its tag. The number of tag data words under an index is said to form a text. The cache is divided into a number of sets of cache lines. Each main memory block can be mapped into any line in a particular set.
Seterusnya, saya akan menerangkan jawapan bagi soalan 2A. Memula, number of set bersamaan dengan 8 iaitu 4 lines kerana 32 bahagi dengan 4 bersamaan dengan 8. Number of block in memory bersamaan dengan size of memory, size of block atau size of block. Size of memory iaitu number of block in memory darab size of block. Size of memory 2 kuasa 2 darab 2 kuasa 10 darab 2 kuasa 7 bersamaan dengan 2 kuasa 19 bagi size of memory. Seterusnya, size of block bersama dengan 128 bersama dengan 2 kuasa 7. So, size of block bersamaan dengan 7. Untuk formula mencari tag, size of memory tolak set tolak size of block iaitu 19 tolak 4 tolak 7 bersamaan dengan 8. Jadi, tag adalah 8, set 4 dan size of block 7.
Seterusnya, saya akan menunjukkan jalan kira bagi soalan ini. Yang pertama, address len set tambah word sama dengan 4 tambah 4 sama dengan 8 bits. Yang kedua, number of addressable unit 2 set tambah words of bytes sama dengan 2 kuasa 4 tambah 4 sama dengan 2 kuasa 8 sama dengan 256 words bytes. Yang ketiga, block size 2 word of byte sama dengan 4 words of byte. Yang keempat, number of block in main memory 2 tambah 2 set tambah words per 2 words sama dengan 16. Yang kelima, number of lines in set and number of set. K sama dengan C per block size sama dengan 32 per 4 sama dengan 8 lines.
Seterusnya nombor 6, number of set line per set size sama dengan 8 per 2 sama dengan 4 set. Nombor 7, number of lines in cache and size of cache. M sama dengan K darab 2 kuasa 2 sama dengan 8 darab 4 sama dengan 32. Seterusnya nombor 8, size of cache. K darab 2 ditambah W words of bytes sama dengan 8 darab 2 ditambah W sama dengan 8 darab 2 4 tambah 4 sama dengan 8 darab 2 kuasa 8 sama dengan 2048. Yang terakhir, set of tag. S sama dengan D bits sama dengan 4 tolak 2 sama dengan 2 bytes. Ini adalah mapping bagi soalan ini.